This video here is for section 8.4. Section 8.4 is actually not too bad uh, in terms of concepts or anything. 8.4 is looking at the lengths of curves or arc lengths. And you learned back in geometry how to find arc lengths of circles by taking whatever fraction of the circle it was times the circumference. However, here, because these aren't circles, we're dealing with just curves of functions or relations even. Uh, then we have to do it a different way by using integrals. And what we're talking about here is they're called smooth curves. They're not necessarily going to be functions, they just have to be smooth, meaning that our relation must be differentiable. So corners, cusps, vertical tangents, discontinuities can cause problems. And we'll talk about those at the end of the video. But what it basically boils down to is that to find the length L of any curve, any smooth curve, meaning it's differentiable, it's going to be the integral of the square root of 1 plus the derivative squared. Uh, and for this, it's a little strange because of the fact that we can do this either with respect to x or with respect to y. So like with area and volume, we kind of pick whichever one's going to be easiest for us. Most of the time it's going to be with respect to x. Sometimes it'll be with respect to y. So an example of this would be, let's say I want to find the length of the curve of this function when x is between 0 and 1. So to do this, the first thing I need is I need dy dx. And following my power rule here, I'm going to get 2 radical 2 times x to the 1/2. Then my length is going to be the integral, and it gives me the bounds, which they'll always give us the bounds. If not, it would be intersections, but I've never seen one that's not given as bounds. So from 0 to 1 of the square root of 1 plus this derivative squared. So this actually can be simplified to be the integral from 0 to 1 of the square root of 1 plus 8x dx. Now, for this, we could do this by hand by doing a u substitution in order to save time. I just did this on my calculator, but this would be 2.167. And that is how long the curve for this function is from 0 to 1. Now, we do have some special cases we have to worry about here. What if the curve is not smooth, meaning vertical tangents, discontinuities, corners, or cusps? Now, to be honest with you, discontinuities, we can't really do much about. Those pretty much ruin things for us, but especially if it's a vertical tangent, or not a vertical tangent, a vertical asymptote. Vertical asymptotes we can't do anything with. Corners and cusps we can deal with. Vertical tangents we can deal with. With vertical tangents, what we do is that since a vertical tangent means that it's momentarily coming vertical, instead of doing this with respect to x, we switch and do it with respect to y. So y equals the cube root of x does have a vertical tangent at 0, 0. So if we switch this to be with respect to y, it removes the vertical tangent, because with respect to y, it's not a vertical tangent. Just do your head tilt to see that on the curve. So then my dx dy would be 3y squared. And so the length would be my integral of 1 plus the 3y squared squared. And this is now with respect to y, so that means everything, including my bounds, are y's. And so my bounds are going to be the y values from -2 to 2. And this is going to equal 17.261. If we have a corner or a cusp, The way we do this is we just split the integral into pieces. So one piece is going to just go up to the corner from the left, and then the other piece starts at that corner. So because a corner and a cusp, and this also works for point discontinuities and jumps, those all occur at points, and a point is infinitesimally small. They don't affect the length. So here, because the absolute value, there's a corner at the absolute value, there's going to be a corner at x. So that means if x is less than 0, uh, we can write this as y equals x squared plus 4x minus x, because x being less than 0 means absolute value is the negative of x. If x is greater than 0, then y would equal x squared plus 4, I'm sorry, not plus 4x, minus 4x minus x. And those can be simplified a little bit. So this means that I'm going to find the lengths. So we're being asked to find it from -4 to 4 total. I'm going to do from -4 to 0 and from 0 to 4. So to do this, I do need my dy dx's. So when x is less than 0, dy dx is 2x plus 3. When y is greater than 0, dy dx would be 2x minus 5. So my total length is going to be the length from -4 to 0, where the corner is, the square root of 1 plus the 2x plus 3 squared. And then going from the corner, 0, to 4, of the square root of 1 plus the 2x minus 5 squared. And this will be 19.556.